Thank you very much. It is an honor to share the room and the stage with so many of my Python heroes, many of whom I've just met in the last 2 days. Thank you to the organizers, to the AV people, all the volunteers. Man, it's a privilege to be here. And I want to be here because I want to make your job easier. You're having fun today. I want to make sure you can have fun when you go back home, when you go back on Monday to your job. So I'm here to talk about how to improve your code without losing your mind. And I know I can do this because I've done a lot of research, and there are a number of things that come up time after time about what us developers really enjoy. And a lot of this is shown in this story I got from this developer, Alex Everloaf. He's a senior level developer who works for a company, and got transferred from one development team to another. And even on day one, he knew he was in trouble. He said he could not make sense of the code base, and he felt frustrated. He had 19 years of programming experience, including several years in the stack that this project was in. Yet, a simple task would take him far longer than he ever thought possible. He felt dumb and helpless. He wasn't alone. The entire team was struggling through technical debt that was keeping them from meeting their deadlines. And as Alex said, leadership did not care about the code quality. As long as stories were delivered on time, corners were cut, and tests were skipped. Now, I don't know about you, but this reminds me of every project I was on. I'm not one of those developers who got to be on one of those teams that had big test, suites or pull requests and reviews. We just try to get stuff done. And honestly, I gotta say, I gotta cut leadership some slack. They have a lot on their mind, and they're not in the code. They don't understand how good code quality can help us. So it's on us as developers to make sure that we have good code quality. They have so many other things they need to worry about. If they have to worry about code quality, something is wrong. And that's what happened with this team. So what do they do about it? They had an honest conversation, both developers and leadership, and they tried to figure out what they could do. Initially, the developers said, you know what? We need to just stop development altogether and clean everything up. The leadership pushed back and said, that would be nice, but we've got bugs we need to fix. We've got features we promised. We can't do that. But is there some way that we can negotiate something in between? At length, they decided, how about every other Friday, we'll reserve the entire day to do nothing but clean up the code. As Alex said, initially, it was hard to defend spending 10% of the team bandwidth on cleaning our code. But the results were huge. So what kind of results did they see? Oh, first I should say, neither Alex nor anyone in his team decided they were going to try to figure out some kind of metrics to see what things are like before and after they do this, right? They just went whole hog into it. And so even though there's no quantitative data, they were clear results. First, code quality improved, which you kind of hope so, right? Because this is the whole exercise. But outside of those Fridays, they were able to start delivering features faster. Additionally, it nearly eliminated all embarrassingly unnecessary incidents. And when developers were developing a feature and they were coming up against a deadline, they were better able to make better judgment calls as to how to cut corners and fix them a lot quicker. They also enjoyed their work more and inspired other teams to do the same. Now, I've been talking for almost 5 minutes. I want to say this next slide might be the most important in my entire talk, so please pay attention. Most of us are too focused on getting features out the door. If we regularly take even a small percentage of our time to improve our code, we can reap huge benefits. Now I get this. This slide is not just for you, it's for me too, right? The current project I'm on, I feel the need to get features out, right? Because this is the people who are paying me, they want features. I want to give them the value. I want to be a good employee. But the truth is, we have more flexibility in our deadlines. This is self-imposed, right? I feel the need. I feel I have to get this out. But if we focus on getting features out, we don't get to iterate on our ideas. We don't get to improve the customer experience or the developer experience of our projects. We don't get to try out new cool frameworks or design patterns or anything. We just get features out, and it makes our code harder and harder to work with. We need to refactor our code, and I'm going to show you how. I'm going to do it by, if you are not familiar with refactoring, I'm going to introduce the idea to you, show you two kinds of refactoring, go through an example of refactoring, really drive home why you should refactor, and leave you with a couple of resources. But first I'm going to back up and introduce myself. My name is Chris May. I'm a Python technical coach. That means I have the privilege to come alongside of teams and make lasting change in them by improving the way they write code and the way they communicate. I propose this talk because there's a misunderstanding of refactoring that held me back. Not just me, not just my career, but the teams I've been a part of. And I see it in the developers I work with every day. And if we can clear up this misunderstanding, I think it'd just make a lot of our lives easier. Let's talk about refactoring. What is it? Refactoring, the definition, is improving code without changing its behavior. The reasons we refactor include to make code understandable, because understandable code is easier to maintain, has fewer bugs, and is easier to fix. Additionally, we refactor to support new directions. This is because your project right now is created to do one or a couple specific things. But we humans are horrible at figuring what the future is going to be like. And there's going to be a time where we're like, you know what? Somebody's changed their mind. We're going to go in this direction. So if you refactor, you kind of make your code more flexible to support the new directions. So that's what refactoring is. I spent a couple years researching refactoring, and I've found that the advice on refactoring pretty much falls into two categories. I call them top-down and bottom-up. Top-down refactoring advice is probably what you've heard of. It essentially comes from this book from Martin Fowler, Refactoring. And essentially what Martin did was, for decades, people were trying to figure out how can we make our code easier to work with. And Martin kind of did his research and talked to a lot of engineers because they kept inventing ways to do this. And he curated a bunch of ways a bunch of specific methods that we can clean our code. One issue with this is that his book and a lot of these people were in Java and C and other languages that are not as flexible as Python. So if you look at any advice out there, chances are you're going to have to choose some translation into Python. One thing interesting about these type of advice is that I call them destinations, right? Because the people who write this advice, they don't know anything about your code. What they do know is, based on the decades of our history, we know if you do these steps, you can improve your code in this specific way. You just need to choose which specific way you want to improve your code. Now, these are intimidating, right? I mean, there's over 60 in Martin Fowler's book. I'm aware of over 70. But what's really neat is if you take your time to just slowly read through them, it's a great way to help you to see what's possible. But if you want kind of the Cliff Notes version, if you want to try to do this on Monday, the things they kind of all have in common is to ensure that tests cover what you want to change, duplicate your code that you want to change that code to cover all the use cases, reroute your original code to use the new code, delete the old code, and run your tests. So that's top-down refactoring. Bottom-up is entirely something different. Instead of having these design patterns that you apply down onto your code, you start with your code itself. And there are a series of rules or steps that you apply to your code and let design patterns emerge from it. And one thing that's really cool about this is that because they're not tied to a specific language, they're good for even data science and pandas or functional programming. And the book that really codifies this bottom-up programming is this 99 Bottles of Object-Oriented Programming by Sandy Metz and Katrina Owen. In this book, Sandy and Katrina wanted to make a great book that helps people understand how to make great object-oriented code that just makes sense and is simpler than a lot of object-oriented code that's out there. But as a part of this, they were like, we need to explain to people how to refactor their code in a way that is simpler and easier to understand, not those 60-some-odd methods. They spent 2 years working and not giving up and trying to figure out a way to do this. And honestly, I am just so impressed with these women that they stuck with it and they created these things. What they did is they created the flocking rules. On the left is the flocking rules, the steps of the flocking rules. And on the right, I have code that generates the first 2 verses of the 12 Days of Christmas. Why not? So let's walk through a quick refactoring just so you can get experience of what the flocking rules are. To start, we identify what we're going to work on. In order to do that, we identify the things that are the most alike. In this case, it's quite simple, right? We have 2 verses. These are things that are the most alike. Next, we identify the smallest difference between them. And I would suggest the first lines are exactly the same except for the third word. So let's focus on this. And what we do next is to make them identical. Before I do anything else, I'm going to say from this point on, we're going to run tests every step of the way just to make sure that we don't introduce any new bugs or change behavior. First, we need to create a component to resolve the variations. The idea of this is that as we are making these 2 things identical, there's going to be a point where differences just stick out like a sore thumb. So we need to create a parameter, a function, or a class that we can call and say, here's the state, this is where we're at. Can you tell us the value we need to use? And if I don't know, in order to create something, we need to name it. And if I don't know the name, like I know exactly what to name it, if I don't know that, there's an exercise that Sandy and Katrina taught me, which is to create a little table to show what needs to be true. So in this case, when the variable verse is 1, this thing needs to return first. When it's 2, second, 3, third, 5, 5th, 12th, 12, 12th. So when I look at the relationship between these pieces of data, the word that starts to come to mind, at least in this case, is nth, right? Take the nth version of 3, it's third. So I'm going to create a function called nth. I'm just going to create it, run our tests. I didn't accidentally mistype anything, so our test passed, we're good. We move on. Now we implement code to supply 1 variation in our nth function. So I suggest we just do return first, run our tests, we're good. Now we're going to replace one of the differences to a call to the component. So if we go to our first verse, we turn it into an f string, we run our tests, we're good. Next step, we can delete any unused code. We don't have any, so we move on to the 5th step, which is to essentially just go back through step 2 until everything is the same. This time we can skip step 1, and now we can implement code to supply the other variation. Just like this. We run our tests, and they fail. This is why tests are so important in refactoring, because you can just focus in on one train of thought and accidentally let in bugs. And what happened here was when I wrote this code, I introduced a parameter to the nth function in a specific way that verse 1 does not support, right? We don't have a variable or a parameter there, an argument. So the best thing we can do is change the code we just introduced to put a default parameter in here. Now we can run our tests, they pass, and we move on. Next, we replace the other component, or the other difference with a call to the component, just like that. We run our tests, they're fine. We don't have any unused code, so we go back up. And this time we can go down to step 3, essentially go back to the first verse, add the parameter in, run our tests, they pass. Now we have code to delete, because now we can delete the parameter. And our code is refactored. Our first line is exactly the same, and we have something elegant that can return the values. Now, I took a couple minutes to go through this, but in reality, when you practice this, it goes amazingly quick. And one thing I love too is that you always have working code. So if you need to commit or get pulled away, your code's always going to work. If you lose your place because it's been a while, you can come back, look at the flocking rules, and pick up right where you left off. It's really impressive. So that's how you can refactor. I want to inspire you to refactor. 3 minutes into his talk in PyCon 2016, Brett Slacken said these words: "Great programmers write code that makes so much sense, it's easy to understand. But most programmers stop at the point where their code works functionally. But great programmers continue on and refactor their code base so it's easy to understand and is obvious. They do this because it provides a better foundation for the future. Over the long run, it saves you time. So I thought it'd be great to show you an example of this. So I got this code off the internet, off GitHub. It's a refactoring kata or exercise that you can download. And this code generates prices for ski lift tickets. It's an API endpoint that you can call. And it's kind of gnarly, right? There's a lot of ifs and elses and all this logic that my brain is not good at. So I decided to refactor it once and created this code. And what this code does, it's the API endpoint calls my computed price function, which is at the very top. And that function creates a specific ticket class and asks for its price. And then the rest of the code is I have a base class of a ticket. I have a night ticket class because that's a specific kind of ticket. I have a way to calculate its price. If I scroll down, there's a normal ticket or a day pass and a way to compute its price. And I feel like this is a lot better. If you need to change the way the night ticket price is calculated, you know right where to go. But I don't think it's quite as understandable as it could be. So I challenged myself some other time. I restarted this whole process, and I really wanted to focus on understandability. And this is the code I created. And I was surprised at how little code it took to do everything that the first code did. And this actually does a better job of explaining the business rules. So I think this is part of the idea that Brett had when he spoke these words. But what I find really interesting is those words are really powerful, but as he was saying these words, he had this slide on the screen. He was trying to say that there's a scale of developers, as he sees them, who spend, the better programmers they are, the more time they spend refactoring. Now, I think he's been a little self-deprecating and put himself in the top category, but the thing that really stopped me in my tracks was when he said the best developers he knows spend almost half their time refactoring. Half their time refactoring. Alex and his team were trying to get 10% of their time to refactor their code. Brett knows people who are spending half their time refactoring their code. I just can't, that thought surprised me. Separate from this, I also asked a developer one of the best developers I've had the luck to meet, Heinrich Schlauach. He created adders or data classes, essentially. And I asked him his thoughts on refactoring. And he told me, I don't really think of refactoring as a separate thing. It's just the result of having tests and thinking about the design of your code all the time. And the more I thought about these two data points, I realized that there was this it didn't match with my experience. The teams I was on, we treated refactoring as something that maybe you do once or twice a year because it was painful. You pretty much got like a senior level developer to go off by themselves to improve some part of the code. And after a couple of weeks, they'd try to come back and bring their code back in line with the rest of us. And then we had to go through the merge conflicts of trying to get it all to work together. And it was just it didn't seem like it was worth it. I'm sure in the long time it was. But these two people are essentially saying, this needs to be a part of your daily life. And as I thought about this, I started thinking about authors or songwriters, right? If there's a book that you love or a song that you really, really enjoy, that content was not the rough draft of whoever wrote it. And that's because the best writers ruthlessly edit their work. And the best Python developers do the same thing. And that's not all. If you really want, I want to drive this home. I think a lot of us just don't refactor enough. And so I want to go back to Alex's example because I kind of glossed over the last two bullet points. There were people who worked around Alex's team who interact with them probably at kitchenettes and things like this. And then one day they were like, what's changed with you guys? You seem so much more happier. You're joking around. What changed? I want some of that. And they're like, well, we started refactoring our code. 10% of our time. And man, if just a little bit of refactoring can improve your lives, I want you to be able to do this. So, if you need to know how, here are some steps. One, ask a Python meetup to do a refactoring night. There's my Python meetup groups all over the place. If you don't feel comfortable joining one or don't know one, I run the Python user group in Richmond, Virginia. Reach out to me, and I'll create an online refactoring night. We'll have a great time. Two, talk to your teammates about it. Having somebody to walk with you would be a wonderful experience to have. Chances are it's going to take ask a couple of times, and you might finally hear somebody say, "What's that you're talking about? I'm kind of curious about it." But it'll really help you out. Next, I suggest putting a meeting on your calendar every week, say like on a Tuesday morning or a Friday afternoon, where you spend 10 minutes just to read through a code smell or refactoring method, just to get it into your mind. And finally, practice as often as you can. There are katas or exercises that you can find online that can just give you practice, because this is essentially a new skill, and so the more you can practice, the better off and the quicker you can do, and the better refactorings you can make. With that, I also wanted to leave you with some resources, because I know there are many people I interact with, a lot of people on my teams who just love a book that they can dig into and really dive in deep on a subject. And there's so many great resources, but I thought, was there a way I could narrow it down to just 3 I could recommend? So the first one I recommend is 99 Bottles of OOP by Sandy and Katrina. They are Ruby programmers. Their book is in Ruby. They've made PHP and JavaScript versions, so if those are more comfortable to you, that might help. But Ruby, the way they write Ruby doesn't require as much translation over to Python, so it's still very worth reading. And if you do have problems translating it, reach out to me, because just by practicing the way that they've coded, I learned so much, and I'd be happy to work with you. So that's a Ruby source. I wanted to find a good Python source, and so the one I'm going to recommend was put out last year. It's called Robust Python. Patrick has done an amazing job of essentially, he teaches you through this book how to make good Pythonic code with stuff that's there, like type hints, like all the stuff that's been in Python in the last few versions. I feel like he does a really great job of really helping you to write great code that communicates with your teammates really well. He doesn't cover a thing about refactoring, but as somebody who starts to refactor more, you can use his book to see oh, I kind of want to lean more into this direction because I need to communicate this way with my teammates. Finally, I wanted to come up with a good refactoring resource that was very Python focused. And honestly, I couldn't find one. So I created one myself called the Python Refactoring Toolkit. It's available on my website if it's something that's interesting to you. Essentially, I've taken my research on refactoring and just put it all together and translated all the refactoring methods I could find into Python, so you wouldn't have to do all that. There's a free version available just to see if it's something you're interested in. But otherwise, that is my talk, and I appreciate you spending time with me today. Thank you very much. I do have one other little request. So this is my first conference talk, and thank you. I walked away from my full-time full stack development job 9 months ago. It'll be 9 months in just a couple of weeks. And so my parents just kind of aren't sure what I'm doing. So I want to take a selfie with you guys just so you can see what's going on. So everybody wave. All right, thank you so much.